with Paul Sagel, who is the chairman of the Water Plant Construction Committee, our new water plant, and he's going to walk us through the new water plant today and how our system works. Thanks for coming out, Paul.
Thank you, Larry. I've been wanting to do this for the residents of Fountain View. You know, our water is a very precious commodity that we have, and it starts up here by the clubhouse. I'm leaning on the well that actually sucks the water up out of the ground. Our wells go down about 200 feet into aquifers, which are underground rivers, and we pump that water up there for use in purification and drinking water for us. We have two wells, one here and the other one is over by the shuffleboard court. And they have to be separated like this because if you put them right next to each other, we'd end up sucking the aquifer down and get lower quality water. So we get half our water here and we get half over by the shuffleboard court. When this water is pumped up out of the ground, it is just virgin water that's running through rivers underground at about 200 feet. The county and cities typically go down 1,500 feet to get their water. So we are not quite as deep as they are, but the quality of the water is great. And what you see here that Larry has taken a picture of is the actual well is here, and it is sunk down and has a well pump down there at 200 feet. The water comes up, goes through a flow meter so we know how much we're pumping, and then off to the water plant. And we're going to go back there and see what happens next. Well, this is the second well that we spoke of. It's separated by at least 200 feet from the first one so we don't fight each other for the water. And this well is actually running right now, but you can't hear it. If you look here, you'll see the meter is moving. That's because we're sucking water out, going through the pipe and back to the water plant right now. There's always a lot of high water demand in the morning for showers and laundry and that type of thing. So let's go back and take a look at the water plant. This is the new water plant. In the front of the building, right behind me, is the pump room and laboratory room. Behind that wall that you see right there is the water tank where the water is stored. It's coming out of the wells that we just visited. I want to take you around the back of the building and show you where the water comes into the building. What you're looking at here is the water that is actually coming from the wells. This big 6-inch pipe here comes from the wells and goes up, way up into the top of the building. We're going to go in there and take a look at that in a minute. But that water is being treated by our sanitizing agents, which are in here, and they are pumped into the water as it comes up from the well. We've got quite a bit of wiring, as you can see in here, to take care of the water plant. We have sensor systems and we have pumps that pump the water out to the park. These pumps that you see here in front of me are the pumps that take the water from the storage tank behind me, and pump it out to the park. We have two of them hooked up right now. We have a third spare one that's sitting over there. And the reason it's not in is because when we brought in the tanker truck, we had to put a special pipe in here to bring water from the tanker truck to the pumps so that you would have water in the park. Now we're going upstairs to take a look at the water well. We're upstairs now, and in front of me is the water storage tank where well water is stored, and it's already been treated with the sanitizing agent. Down there you can see what we call the shower head. The water is intentionally splashed very much so that any gases that are in the water can be eliminated. It's sucked out with the fan down at the end. This building that we built has a dust and dirt shield that you can see up here to keep dirt from falling down into the water. And it also has a screen wall here so that if any flying insects get in here, they can't get into the water that's stored here. This water is about 18,000 gallons, and it refills about once every 2 hours. Right now it's just about up to the fill line you can see on the wall. And when that shuts off, it'll continue down to the pumps that we just looked at downstairs. With that, we're going to head back down. There's a catwalk here, as you can see, if we have to go over and service that jar head or work on that fan. Sure. This building is all new. Below us is the laboratory area. And all these trusses and all the roofing is new. None of this was here before, as you've seen in the videos, that the pictures that we have from drone shots. This was destroyed, and now it's back. Well, we're back down here in the pump room, and I want to show you, we have a sight tube here, so we don't have to keep climbing up and down the ladder to see how much water is in the storage tank. So on here you see some different colored tapes, okay? This red tape at the bottom is as low as we let the water go and shut the pumps off. So the system will not operate if the water gets down to this point. The water operates between the blue and the blue for the float levels. And this is the high water mark. If water gets this high, everything shuts off too, so we don't flood the building and cause a disaster in here. When the water tank gets low, it calls for water from the wells way up by the clubhouse. That's all controlled by this box here, where we can select the wells, have them come on automatically and refill the tank, or run them manually if we have an issue. And we can also control which pumps are being used to pump up the pressure to the park. We alternate back and forth so we don't wear out one pump prematurely. Side now, that water that was being pumped out of the building comes into this tank here. This tank is a 6,000 gallon tank, and it's about this full of water. We have to keep air on top of it so that it doesn't hammer, where it goes bong, bong. So that's like a shock absorber. And we adjust that with this sight glass to say how high is the water and how much air do we have. This system feeds the whole park, and when we have to shut the park off, we do it right here. I want to point out that while we're back here, there's a second tank and a completely separate system from our drinking water. That's the irrigation water. It's in this tank. And what you can see, if Larry can get there's a hole in it. And that's what happens to these old tanks. They're 40 years old and they rust through. These tanks are being replaced. This will be replaced by a 2,600 gallon tank. This one will be replaced by a 6,000 gallon tank, just like we have. We are going to replace both of these tanks. The potable water tank needs to be replaced because we're required to have them inspected by an engineer every 5 years. And 5 years ago, they said this tank needed to be replaced. And I guess, we didn't believe them, I don't know. But this is what happens. They told us this one was bad too, and it rusted through. We think this one's not far behind, the potable water tank. So it's being replaced in January. We'll have 2 new tanks here. Throughout the park, you'll see red faucets and blue faucets. The red faucets are the irrigation water that you use to wash your house or whatever, water your lawn, whatever. The blue faucets are our potable water that we can drink, and they're there for flushing purpose and testing. So samples will be drawn throughout the park to make sure the water is pure and has the right amount of sanitizing agents in it. Just like we had pumps inside, I want to point out over here, these are the pumps for the irrigation water. So the irrigation water is drawn out of Lake Erica through this well. This is actually just a big deep hole that is connected to Lake Erica. So Lake Erica's water can flow back here and be used by our pumps to satisfy the irrigation system. They are 2 separate systems and never cross each other. That is one of the rules of making sure our water is safe, is never have anybody connect the irrigation water to the drinking water. By law, we're required to have a backup power generation system for our water plant so that if the electric goes off, we can still provide water to the park. This is the system we bought about 6 years ago, and it provides the power to the water plant. And there's a second one of these generators up at the clubhouse to power the wells. So we've got 2 generators to satisfy water needs in case of storm outages.
Paul, thanks very much for this thorough overview of our new water plant and the water system and how it works, and certainly appreciate your work as chairman of the Water Plant Construction Committee. And also, Paul, who else is on that committee you'd like to give thanks to?
We have great people on our committee. We've got Tim Levine, who has worked tirelessly. While Tim's not here, he spent lots of hours on the phone every day trying to get supplies, arrange payment contracts, and everything we need for here. He's been a tremendous asset. Dan Hatfield is on our committee as well, and he's an electrician. He actually came back and made a schematic of the wiring that was in the plant here. Without him, we would not have known how many different control systems we had. And lastly, Gary Tyler was our board representative on the water plant committee. It's been a lot of work, but I think we're there. Enjoy the water.
Thanks a lot, Paul. And I know now the boil water notice is now over and we can start using the park water for drinking.
That's correct. Enjoy it. I hope it tastes good for you.
Thanks for everything you've done, Paul, and your committee.
Okay.